Hooray! Lesson 3! No, I'm just kidding. I would like to welcome you on this lesson 3 of Schematic and PCB design course. And this week we are going to speak about component selection and libraries. Why component selection, or why it is so important? Because when you use a component which is not possible to buy, you can build your product. If you use a component which is too expensive, your product is very expensive. You know, there is a connection. So to make a decision which component is the best for the design, we need to know some parameters when we are using the component in the schematic, in the design. And now maybe think a little bit what is the way how you pick a component for your design. You know, imagine you are going to use a new microcontroller in the schematic. What do? Are you going to manufacturer website, or you are going to a supplier website? Because going to the manufacturer website is not the best option. It can be done more efficiently if you go to supplier website. Why? It's easy. I will explain it because then you may remember it better. If you go to manufacturer website, you need to go through all the items, what they do, and you may not find your chip. So you need to go to a different manufacturer website and go again through the items they do, and again, maybe it's not there, maybe it is there. You may visit more manufacturer websites, even compare between the products they do. And this can be done more efficiently if you use a supplier. Let's say DigiKey. I use DigiKey for most of my components because they have really good stock and really a lot of components. Let's say we want to buy, I will use a simple example, but you can apply it for any component. We need to buy a resistor 10K 0603. Yeah, I just pick here 0603 10K, and I want only the components in stock. What happened? We actually saved a lot of time because we see in one result, we see all the manufacturers on one website, so we don't need to go through all the manufacturers. You see all the parameters in one table. You also see, for example, the minimum quantity. That's really important because you don't want to use a component which has minimum ordering quantity 1000 pieces if you are building 5 pieces. That's too expensive. So I click on this one. You immediately see what is the manufacturer part number. When you need to build manufacturer part number from datasheet, first you can make a mistake, and secondly you may even not find the part. It may not be possible to buy it. Yeah, you may spend hours of looking for the component which you can build, and you may not buy it. If you look directly in supplier, you are pretty sure you can buy it because you see they have it in stock, you see the price, you can buy it in one piece, and you also see the ordering information. On the top of everything, you can also download datasheet. You just saved huge amount of time Just use one search. That's it. There is another thing when you are looking for the components through supplier instead of manufacturer, and the benefit is you don't need so many suppliers, because if you pick a special component from a manufacturer, each manufacturer may have different suppliers. So what you may end up with is you want to buy 20 different components, but you need to buy them from 10 different suppliers, and then you need to communicate with each of these suppliers, change a couple of emails, maybe call them, and also you need to pay delivery for each of the components from each of the suppliers. So if you order as many components as you can from one supplier, you will save time and you will save money. Pick two biggest suppliers. I use DigiKey and Farnell, and use them for most of your components. Then you can enjoy the time which you save. You can enjoy it with developing another great products, and spend it with a creative working on the schematic, not looking for a component. Let's go to the Webpack schematic and learn something new. And this is really important. Many engineers create components this way. Copy and paste. If I need 1K, I just double click. 1K. Yeah? Do you do it this way? Yeah? So, there is a better way to do it. I used to do it this way too, don't worry. Because I had no idea there is a different way how you can do it. What's wrong with this? There's nothing wrong if you work on your hobby project, or if your project is like 10 components. It's okay, it's just fine. If you design boards with tens, hundreds, thousands of components, if you have more projects, 5 projects, you may work with like thousands of components, and it would take you huge amount of time to manage all these components. Why? Because when you generate BOM, bill of material, the list of all components in your schematic, the list of components which you have to buy, everything what you can get, all the information which you can get from this kind of component is like R307, 1K, 0603, and that's it. You need to manually go and add information like manufacturer, manufacturer part number, supplier, ordering information for each component in your BOM manually. Now I give you an example. This is a BOM from one of my projects. You see, all this information is here: category, manufacturer, manufacturer part number, package, description, quantity, supplier, supplier part number, and even dynamic things like supplier stock at the time when the BOM was generated. This BOM was generated, just press one, click, press one button, click. There is nothing manually edited, because if I had to edit this BOM, have a look, it is like 195 components. If I have to go and edit each of these components manually, I would spend ages of doing it. And for example, if I have to do different version of the board, or if I reuse the part of the board and I have to do it again and again and again, all these 200 components, put there all the information, copy, paste, you can make a lot of mistakes. But as I said, this one was generated automatically. Just press one button and you can do it too. It's really simple. Everything is hidden in these parameters. These parameters are exactly the fields which are here. Yeah? These are the parameters. This is the value of the parameter. So if I put here like, and here example you can use then these parameters in your BOM. And there is a really simple way in Altium Designer to import these parameters directly from supplier. So you don't have to do it manually. Let's speak about this after the bonus. For today's first bonus, I decided to speak about ESD testing. You are really clever, so you know what ESD means. You know when your body is charged and you are going to touch something, there may be a spark coming out of your finger, and this spark actually may damage a electronic circuit. That's electrostatic discharge, and this is pretty common in environment like offices and home. So it's really good idea to test your devices for ESD immunity. But before you send it to official house, it's always also good to be sure it will pass the official test, because the official test costs a lot of money. How you can test it at your lab? What you will need is this kind of gun. This is the ESD gun. Just put ESD gun into Google. It will find something like this. And what the gun actually does is it is capable to send the electrostatic pulses into your device or emulate it. You will also need a kind of setup. Something like this, with a ground plane, with a small table, few other things, and your device. And then what you do, you are doing a couple of tests. There are actually two basic tests. One is contact test and one is air discharge test. The contact test is when the gun is actually touching your device. The air discharge is when you are going closer, and then there is a spark, going through the air between the gun and your device. As you can see, the air discharge goes to higher voltage comparing to the contact discharge, and these maximum voltages, it depends on the kind of device you are developing. So on the gun you can set different voltages, and also you can set different polarity, because you need to test the positive and also the negative polarity. You don't test only one pulse, you need to test a lot of pulses. I think I saw somewhere in this article, which I will attach to the video, I saw that they are saying 200 pulses. On the gun there is a counter. So when you press and when you hold the trigger, you will see on the counter how many pulses went to your device. You don't need to count them. And you go around your device and test it in the areas where people can touch, you know, keyboards, edges and connectors and all these things, and see what will happen. The device should be running, operating, and in the best case nothing will happen. So you finish all the tests and your device is still running perfectly. That's the best case. What sometimes happens is you may see some problems on your display, or for example the device may reboot or reset, or in the worst case you damage something, you damage the input, you damage a circuit. It is actually happening. I really saw this. So it's really good idea to test your device for this ESD immunity. And that's it. It's really simple. Have a look. You can hire the gun, you don't have to buy it, and you can test your devices before you ship them to the customers or to the test house. Let's go back to the schematic and libraries and imagine everyday engineer situation when you are working on your schematic and you need to use a new component. And you have two options. You can create it, or you can try to find it somewhere. So what is the way which you use? Create it or find it? When I was starting with hardware design, I always tried to find it first. I don't know exactly why. I think I was really scared from creating new components, and you know, I always saw the other people can make it better, and I thought it is faster. But you may be surprised. Now I create all the components by myself, and it's because I actually find out it is faster. In global, it is faster than try to find the component. Why I'm saying in global? Because yeah, you may be right. You can find sometimes a component faster rather than creating it. But when you do it with many components, and you also have a look on other things around it, so the creating is the faster way. What are the other things? The other things is, for example, when you find a component, it may not exactly fit your design. For example, you may need to move pin position, so you may need to modify it, or you may need to also to check it if it's if the symbol, if the component is right. So you have to spend with it some time anyway. And as I said, in global, to create a new component is faster. And I've been told other engineers, other good engineers, they think exactly the same thing. So they create the components by themselves. How to create it? We will start a new library project, and we will add new schematic library. You know, every component has two parts. Schematic symbol is the symbol which is used in the schematic, and the PCB footprint, which is the physical representation of the component, and it is used in the PCB. So we are going to create the schematic symbol now. And let's say we would like to create this 1K resistor. I go to DigiKey, put here 1K 0603. Click here, 0603, 1K in stock. And I normally use 1% resistors for prototypes, so I don't need to, you know, have two reels from each value, 1% and 5%. Everything what we need is this number, and now we go to Altium Designer. I will disappear for a moment. I go to library, and what we will do is this feature which I'm going to show you, I think is one of the best feature of Altium Designer. So have a look, System supplier search. I'll put here the number and press search. What is happening? Altium Designer is checking database of selected suppliers. In my case, I selected only DigiKey. Yeah. And when I press right click and import into my library, it will actually import all the parameters automatically to the new component. So I don't have to create them manually. And in the BOM, I can then very easily use the parameters like manufacturer part number, you know, supplier part number. I don't have to write it. It's there. Now everything what I have to do is hide this and draw the symbol. So I place pins. I will draw the outline. I will change grid. I will hide these numbers. Double click on the component, and I need to fill this information and 1K. The comment is the thing which you can see in the schematic. For most of the components I use the command part number. Why? Because, for example, even for inductors, when I use part number and the schematic is printed in PDF or on the paper, it's very easy based on the part number to find the exact inductor which is used in the schematic. It's much better than if I just say 2 nanohenry. Yeah, it doesn't say anything about the inductor. So I mostly use exact part numbers in the comment. I delete this. I will now save the library. You know, into design files, Altium specific files. I will call it my library. Again. Okay, and now I will compile it. I go back to my schematic and I can use this component which I just created. Difference between this component, this one doesn't have any parameters. This one have them. So if all your schematic is based on this kind of components, your BOM can be generated, just press one click and you don't need to edit it manually. All the information, all the per searching information, part numbers, everything is there. You got it, you understand now, yeah? So you may think, oh, but it was much slower than, you know, copy and paste. To create similar components, it's much easier and much simpler. Let's say 10K. O603, 1%, 10K in stock. Apply. Copy. I'm doing it because we will also repeat it this way, so you will remember it better. Search, import, hide this, correct this, and we don't have to draw the symbol because we can easily just copy, okay? Control C and paste. So now when we compile the library, we can use also the 10K register. It was pretty quick. And you don't have to spend any more time with this component in future, even when you use it in all the other projects. Even when you copy this schematic, you don't have to do it again, never. So it's really useful. Use it like this way. It will help you a lot. We will speak about the bombs in next lesson, so you will see the benefits. It's the bonus time. And because I received a lot of feedback about the Linux compilation from the last week, I decided to spend few more minutes on this topic. And one of the questions what I received from a friend of mine was how we actually flash the image into the board. That's what I'm going to demonstrate now. Before we start, I explain how we communicate with the board, how we connect to the board, because before I started using ARM boards based on operating system, I had no idea how actually you can communicate with the board if there is no display, for example. Mostly or most used interface is serial port or Ethernet. These are two ways how you can connect to a ARM board if there is no display. So this is the serial terminal, and now I'm going to switch on a board, one of my boards which I designed some time ago, and because it is quite powerful I need to switch on fan, so you will hear a little bit noise. I'm connecting the board, and what you can see here is the bootloader which started. There are plenty bootloaders. This one is called the U-boot, but they all work exactly the same way or very similar. So it starts the CPU and memories, and this is the command line of the bootloader. What you can do with bootloader? You can use several commands, and we need to do basically 2 or 3 things. One is we need to flash the kernel and file system into the memory. We need to be able to download these files through Ethernet, and we need to be able to set up the bootloader into the automatic mode when we connect a power and the operating system automatically boot up. You know, it will not finish in the bootloader, it has to boot up automatically. So this is the command line used to flash the kernel. What it does, as I explained, it starts communication with server. The server is actually this Linux virtual machine. We have there our file, which is downloaded through TFTP to the DRAM memory. Then flash is erased, and then the file is written into the flash from the DRAM memory. Same for the file system. We download the file system file and then erase and flash it into the memory. The file system itself, it is actually one file, and chip manufacturer, they will explain how to create this file, but basically what it is, as I explained last week, it is your hard drive. In this one file there are actually all the files which you normally have on your hard drive. And now we have to set the command for bootloader to tell the bootloader start the Linux automatically with some parameters. And that's it. Now when I disconnect the power and I connect it again, you will see what will happen. Bootloader started. Now automatically it reads the kernel from flash and loads it to memory, reads the file system from flash and loads it to memory, and it starts the kernel. So it wasn't so difficult, but I'm sure you have now idea how it works. During development it is much easier to work with files which you don't need to flash into the memory all the time. So I'll show you also different way how you can use it. And everything what we will do, we just set up a command for in the bootloader. I will switch on and switch off and switch on the board again, and I will use this command, which actually tells the bootloader to download the kernel directly to memory. So it is not downloading from flash, it downloads it directly from this machine where we just compiled it, and the kernel will connect through Ethernet with a file system which is again located on this machine. So it is much more simple, no flashing. I will switch off the board, switch on the bootloader. Now it's downloading the kernel from this machine directly to the memory. It starts from the memory. Now it's connecting the file system from this machine, and the system is almost ready. It's ready now, and it's running the operating system Linux. So it was, I hope, again something new, maybe for I hope for most of you. And back to our lesson. Now let's go back to our schematic, and I will make another point why it's really good to create your own components. You remember in the first lesson we were speaking about how to import reference schematics. In the second lesson we were speaking about how to put the reference schematics into your own schematic, and then basically what you do in the next step is you need to connect the reference schematics together, because you may have a reference schematic from a power supply, you may have a reference schematic from a CPU, from something else, and they need to use same net names, same signals. That's when you will make the connection. And in next step, what needs to be done is to replace all the symbols from the reference schematics with your own symbols, with the symbols from your own library. Why? Because you want to have all this information in the parts. Now let's say this is our reference schematic, and imagine we are going to try to find this SI4705 on internet, and we are lucky we have it. What may very easily happen is the SI4705 which you found on internet may be actually a little bit different than this one which you need to replace in your reference schematic, because these pins can be actually placed in any order or somewhere else. So there is no one-to-one replacement. And you may need to end up with editing the downloaded schematic symbol, which takes some time again. Luckily in Altium Designer there is a really good feature again which will help you, and the feature actually will create a schematic library from all the symbols used in your schematic. I will demonstrate. Make schematic library. Okay. Voila! Can you see? All the symbols from this schematic we have in this one library. This is really powerful. Why? Because we can then simply just go here, copy the name, remember the footprint, TSSOP24. We can go to our own library. Now I will disappear, go to the system, supplier search. Oh, I already have it here, but paste, search for it. Now I will pick this one, import into my library. Everything what I have to do is hide this, put here U question mark, put here the number. I told you before, yeah? Full number. Then you are clear what footprint is used. Clear when it is printed in schematic, for example. And now I just go here, very simply copy, go here, paste. I'll compile the library. I go here. This is the place where the component is used. Oops, I delete this one, put it here. And that's it. We have a component with all the information we need. Really simple, really useful. And you can create, doing it this way, you can create all the processors, chips and everything, because they are supplied in reference schematics. So don't worry. And you may argue, yeah, schematic symbol is not everything. You also need footprint. Exactly same way you can also import the footprints. So we will speak about this in different lesson, but I had to mention it because it is really important that you can import also the footprints same way. Few more things what I would like to speak about. It's very common and it's happening all the time. Someone is asking information about the component used in your schematic, so you need to open the project and have a look what is the component number. And what I used to do, I copied the component number, I went to Google and I was looking for datasheet, because it is for most of the components it is faster than look in my directory, excluding few special components which doesn't have datasheet on internet. There is if you create your library the way which we were speaking about today, there is easier way to do it. You just simply press right click on the component and select supplier link, and there is a section documents. You just double click and datasheet will open. I use it a lot. It's very quick, and you know, I have to say it again, I just love this feature. What can I do? But go to the library again. I receive questions if there is option to add some replacement. You know, for example, this 10K resistor is not in DigiKey, it is not in stock, so where I can buy it. Yes, you can add additional information, like for example Farnell. So we copy the part number, Ctrl C, and I will click on this add. Be sure you are looking in DigiKey and Farnell and search. And here we go. They have it also in Farnell, so I can just add the component. And what happened is we have new parameters. You can see supplier to Farnell, supplier part number 2 is the Farnell part number. And then when you generate BOM, you can just add more columns and very simply compare availability or compare price if you need. I also add a few more parameters which I use for myself. One of them is, for example, creator. As you can see, I start with dot because then the parameters are placed on the top. You know what the creator means. It's when someone else is creating components for me, they will put there the initials. When schematic symbol is checked, put initials. When footprint is checked, put there the initials. So doing it this way, I'm pretty sure the component is safe to use in a design. If there are no initials, I have to check it before the before board goes to production. But it's much better to check it much sooner. We will speak about it later, when is the best way to check the schematic. It would be pretty difficult to add all these parameters manually to each of your components. So you can do it through parameter manager, and you just can select this. You know, we want to add this, you just press add, and I don't know if you can, there is the window so you can see it. So execute, close, and Yeah, the parameters are here. They are also here and also here. Good. Few more tips. You probably use it this way anyway, but I saw a lot of schematics when they just don't do it. Place the components close to the pin where they should be, because when you do the layout, you know where to place the component. Also, when you create a schematic symbol by yourself, find some kind of way. For example, I place on one side the inputs, on the other side outputs, or on one side I put the bus connected to processor, on the other side something else. Just it is pretty good done in this Webpack schematic, so it is very clear how to connect the things. So finally, that's everything for this week about component management and libraries. And for the people who are interested, I have another challenge also this week. But before I raise the challenge, I will explain my experience with separating digital and analog grounds. Because I designed the processor boards mostly, the analog part what I used a lot is audio. So I will be speaking about my experience with audio and separating the ground. On the very beginning of designing the boards, I completely separated the ground and the powers and everything. When you had a look on the PCB, there was a gap, visible gap actually between the analog audio and the rest of the digital part of the board. Then a friend of mine told me it may not be necessary to separate or use the analog ground, or he actually said it may be even worse. And I had a look on this problematic, and really there is a lot of articles which says separate analog and digital ground, and there is a lot of articles which says do not do it. Of course, it cannot be done or applied for all the circuits, but for some of the analog circuits this may apply. How do I know? Because in my next design, I was still not convinced. So what I've done, instead of placing one resistor on the gap, I actually placed I provided option to place more resistor around the gap. When all the resistors, 0 ohm resistors, were fitted, I some kind of simulated the ground connection around the island. So the island basically disappeared. And what happened when I placed all the 0 ohm resistors and I fitted them was nothing happened. It was working perfectly, clear sound, no problems. So in next design I actually have not separated anything, just full ground, common ground for the analog, for the digital circuits. And what do you think? Nothing again. Everything worked. And actually it was even better than the previous design. How do I know? Because with the first design we had ESD issue. The design guide said place a bead, ferrite, on the ground and on the power. And when the device was tested by the ESD gun, the pulse didn't discharge through the ferrite, but it discharged inside the chip. So it damaged the chip. When we replaced the ferrites by 0 ohm resistor, everything worked okay. In the second design, when I used only one connection, I need to say it was separated somehow, but it was not exactly the right way, and the analog ground was picking up noise. And what was happening, the noise went out through the cables. So when we were doing EMC measurement and EMI, the noise coming out of the cables was quite high. And when I placed all the 0 ohm resistors, it disappeared. And in the last design, everything just fine, no problems. And even, of course, I don't mix digital and analog signals. You know, you have a board, and in small corner, I have the analog, the audio, for example. I try to have it only on one layer in the corner, yeah? Not one layer on whole board. In the corner, I use only one layer for the analog components. I don't mix it with the digital components. And even in one of the designs, there is Ethernet on the top, for example. In another design, there is PCI Express or some other wireless cards. And audio is working perfectly, no problems. And the ground is not separated, the ground is common for whole board. So the challenge for this week is what is better? Separate the digital and analog ground or not? And the goal of this challenge is not to find the right answer, because you know, for some situation the common ground may not apply. The goal of this challenge is to start discussion about this problematic and you know, give you some kind of motivation to have a look on this problematic, because it is very common, and it is you will need to face to this question in one of your designs. A lot of designs are mixed, digital and analog. So when you have a look, you find some articles, you will read them, you will get more background information, which will help you then make the decision in the future. So I'm really curious to see what the answers will be, what people means, what they think, when separate the grounds, and if it's useful or not. Because this week there is only one thing to do, it may look like it is not a lot of work, but it is. So go through your schematic and try to replace all the symbols with the kind of symbols which we were speaking about today. Because in next lesson we will use these symbols to generate the bomb. If we are using the Voipax schematic, go through the Voipax symbols, you know, generate the library, create the new symbols, and test it on by yourself how difficult it may be if the symbol doesn't have all the ordering information. If you, for example, need to find out what is the maximum current for the inductor or for the bead, see how difficult it is. And don't forget about the challenge. Have a look on the problematic of separating audio and digital ground. Thank you very much for watching, and I'm looking forward for the next lesson, so see you soon.